Welcome back to our series on introductory statistics. I'm Mark Ledbetter. This is lecture video 36. We are moving into section 9.2. This is part 1. In the last few videos, we have discussed and understood how to do hypothesis testing for the population mean, mu, when sigma is known. In the next set of videos, including this one, we are going to learn how to perform hypothesis tests for the population mean mu when we do not know sigma, and this is a much more realistic case. It's what usually happens in real life. I hope you enjoy the pre-recorded video. Welcome. In this video, we're going to start section 9.2, but really what we're going to do is we're going to review section 9.1 and do a couple of examples. So I'm calling this part 1 of section 9.2. And that's what happens in the book. In section 9.2, part 1, they review what you've learned in section 1 to try to emphasize and reinforce the right practices for performing an hypothesis test. And this is very important. So this is one of those topics where we need to get it right. This is very critical. For those of you who are going to take additional statistics courses, this is going to really help you in those courses. Anybody in psychology, math, obviously data science or statistics or actuarial science or economics, you're going to have courses that have statistics in them. And so this is really going to be something I hope you can refer back to and use in those future courses. All right. So in the last section, we learned specifically how to find a p-value, which was a new thing to do. And overall, we learned how to test a hypothesis about a mean mu when sigma is known. This is extremely important. When sigma is known, then we can use the z table. When sigma is not known, then we have to use the t table. But we'll talk about that in the next video. All right, so I want to review, and this is exercise 19 from section 9.1 in the book. And it says, let x be a random variable representing the dividend yield of Australian bank stocks. We may assume x has a normal distribution with standard deviation 2.4%. A random sample of 10 Australian bank stocks have a sample mean of x bar equals 5.38%. For the entire Australian stock market, the mean dividend yield is mu equal to 4.7%, and the reference there is Forbes. Now I want to stop and say this is not true ever in real life. Think about what we're saying here. We're assuming this, but it's not really true. For the entire Australian stock market, the mean dividend yield is 4.7%. Even if you could take all of the Australian stock market, it changes second to second. So it's never the same from time to time. So please, the book does this, but please realize that we would never really know mu. And so we could say that we think it's approximately 4.7%, or historically we've seen it close to 4.7%, but in real life we do not know mu. And there is no way to know mu, even with the best computer, because mu is going to change every second as the stock is traded, okay, and the prices change. So it says, do these data indicate that the dividend yield of all Australian banks is higher than 4.7%, okay? And it says use alpha equals 0.01. Now, I have written down the letters in the book on page 434. It says for problems 19 through 24, please provide the following information. So if you're doing these problems and I don't specify anything else, then you need to make sure that you write down and answer each one of these, because I'm going to be grading them. Okay, so the first thing it says, what's the significance level? Well, this is very easy because they gave us the significance level. The significance level is alpha, and they told us that alpha is 0.01. So there's the answer to that part. Quite easy if you know what you're looking for. It says, will you use a left-tailed, a right-tailed, or a two-tailed test? And then write the hypothesis statement. Okay, so a left-tailed test is left, and I'm going to write this pretty small. Actually, I'm going to zoom in so it's not so small on your screen. So a left tail test. I'm going to draw the normal distribution, although it doesn't have to be a normal distribution. And so a left-tailed test, we would have our test statistic. Actually, this would be x bar. We don't know, we'll use the x bar distribution. So we'll have x bar of our sample, and we'll have in this case, we would have our test statistic. Let's say z observed would be down here. And so z observed would have to be less than our mean, x bar. And we would have a p-value that is here. So left-tailed, we're on the left side of the distribution. Now, right-tailed. Again, we're going to have x bar in the middle, but now to do a right-tailed, we would need our test statistic, z observed, would have to be above the mean, and then our p-value would be here. Now, for a two-tailed test, draw the same approximate distribution. Now we're looking at, we don't care if the z observed is down here or if it's up here. The p-value would be, if this is negative z observed, then the p-value would be the addition of these two. So this would be half the p-value, and this would be half the p-value. Now, here, for this left-tail test, we would say h1 mu is less than some value mu naught. So a left-tailed test, we have a less than sign here. For a right-tailed test, we would write our our alternative, our claim, as mu is greater than some value mu naught. And for a two-tailed test, we don't care if it's smaller or bigger, we just want to know if something's different, and so we would write our claim or our alternative hypothesis, something like mu is not equal to mu naught. Okay? So not equal to or different than. So these are the three ones. And so what we do is we go and we find our claim in the problem, because it's always going to be in the problem. And the claim turns out, do these data indicate that the dividend yield of all Australian banks is higher than 4.7%? So it says higher. That means larger. That means bigger. So the answer to this is we're going to use, because we're looking at bigger, that's going to be a right-tailed test. Because this says higher. If it says lower or smaller or less than, then we would use a left-tailed test. If it says higher, larger, bigger, greater than, then we're going to use a right-tailed test. If it says not equal to, different than, not the same, something like that, we'd use a two-tailed test. All right. So now we move on to checking the requirements. What sampling distribution will you use? I'm going to use the sampling distribution of x bar is a normal distribution with mean mu, And variance, sigma squared over n. We learned that from our central limit theorem, but we have to be careful checking the requirements. My sample size, my random sample of 10, this means that n is equal to 10. And remember, for me to be able to use the central limit theorem, n has to be at least 30. But it does say, let's see, we may assume here, it says, we may assume that x has a normal distribution. And we learned that if we have a normal distribution for the data, then x bar is also going to have a normal distribution, which is very nice. It makes it easy. So since we started with a normal distribution, x bar will definitely have a normal distribution. When we have sigma, when we know sigma and x starts with a normal distribution, we have a normal distribution for x bar. Okay. So we're going to use x bar, mean mu, variance sigma squared over n. Now it says find or estimate the p-value. Sketch the sampling distribution and show the area corresponding to the p-value. So I'm going to come down here, and for the requirement checks, I'm going to say n equals 10, which of course is less than 30, but x is normally distributed. So I'm going to put a check mark there to show, hey, we're okay. We can do this analysis. If n was not 30, at least, and x was not normally distributed, then we could not do this test this way. We'd have to use whatever distribution that the data has and do some pretty complex or tedious calculations to do this test. All right. So luckily, we started with a normally distributed data, so we can use this. Now, hypothesis statement. Okay, so I'm always, even though the book didn't say this, I'm going to always require you to write the hypothesis statement. As I told you in the previous video, this is your roadmap. You need to write it down. So it has two parts. The first is the null hypothesis, H naught, or H sub 0 if you would like. And sub stands for subscript, okay? So H naught, we're doing a test about mean mu, so it's always going to be mu equals. And then we have to go up and look at, in this case, the book is being very nice by telling you mu is equal to 4.7%, okay? So we're going to put 4.7% here. And versus H1, our alternative or hypothesis or our claim. So now we have to look back and see what it is we're testing for. And so we come back to what I've underlined here, the dividend yields of all Australian banks, and it should say the mean dividend yield of all Australian banks is higher than 4.7%. So higher than or greater than 4.7%. So it's always mu. It's greater than 4.7%. Well, that's the end of this video. Please remember to scan your lecture notes before midnight of the date listed on the course calendar. If you have questions, please come to virtual office hours. I am very happy to help you, as always. If you can't do that, then you're welcome to email me. But when you email me, I need two things from you. The first is a picture of the problem so that I can help you through email. I may not have the problem available to me. If you don't send me the problem, then you're going to have to wait until I get back to my computer and get that problem pulled up. So please send me a picture of the problem. The second thing you need to send me is a picture of your work so far. This helps me understand how you're approaching the problem and may help me or will help me help you faster and better. So I hope you will stay safe and take care of yourself. Until next time, we'll see you then.